Good evening. Today we're going to derive the Michaelis-Menten equation to help us describe the mechanics of the kinetics of enzymes as they react with substrates. In front of you, you see that there are um, 5 equations, the top 4. V0 equals V max concentration of S over Km plus concentration of S. S stands for substrate. The Km is the Michaelis constant we have. As you can see here, Km is the Michaelis constant. K1 and K2, we'll get into that in a few seconds. But Km equals K1 plus K2 over K1. And then you have Vmax, which is the maximum rate of the reaction, over K2 times the concentration of the enzyme. And then you have the total concentration of the enzyme equals the concentration of the enzyme plus the concentration of enzyme and substrate, as seen with the E in the bracket. That stands for the concentration of enzymes. So our first equation is you have the enzyme combined with the substrate. You see there are a double arrow, one going forward, one going back. K1, as I mentioned previously, stands for the rate constant of the forward reaction, while K minus 1 stands for the rate constant of the reverse reaction, where you have E, the enzyme plus substrate, becoming enzyme substrate complex, and vice versa, enzyme substrate complex can reverse and become an enzyme and substrate. Additionally, that enzyme substrate can also become E plus P. K2 will be the rate constant of that reaction, the second reaction. P, as I mentioned previously, is the product from the enzyme substrate complex that broke apart, but it's different than the substrate and enzyme I've seen here. So we start off with the instantaneous rate of change for ES over dt, and we equal that to 0, which then we equal to K1, as we said was the rate constant of the first reaction, times the concentration of the enzyme and the substrate, minus K minus 1 times ES minus K2 times ES. Again, all of that would equal 0. Just to re-clarify, we have V0 standing for the initial rate of the reaction equals to K2 times ES. Now, before we proceed with the next step, it's important to refer back to the fourth equation up here, on one of the 4 equations we were originally given, and E sub T will stand for the total enzyme concentration equaling to the concentration of the enzyme plus ES. And just so, in case I haven't clarified what ES was, ES is the bound enzyme, or otherwise known as the enzyme substrate complex. And just to clarify, E right here is the concentration of the unbound enzyme. Now, moving forward, we do not know the concentration of ES because ES is formed during the reaction. But we can also assume that ES is very low and that it forms at the same rate that it gets broken down. So we can have right here this equation, K1 times the concentration of E times the concentration of S equals K minus 1 times the concentration of ES plus K2 times the concentration of ES. Given that I had just pointed out the equation for E, T, we can substitute the fourth equation into the equation right here where I just mentioned K1 equals E times S. So now you have K1 times times ET minus KS time, times S equals K minus 1 times ES plus K2 times ES. Then you have K1 times ET times S equals K1 times S plus K minus 1 plus K2 times ES. So now we can isolate this variable ES by dividing both sides by this. And we get ES equals K1 times ET times S over K minus 1 plus K2 plus K1 times S. Moving on to the second part of the equation. So the second part is where we're trying to incorporate the Michaelis constant Km. We're not there quite yet, so we have ES equals ET times S divided by K minus 1 plus K2 divided by K1 plus S. Based off of the previous equation that Km equals K minus 1 plus K2 over K1, we can substitute that into here and we get ES equals ET times S over Km plus S. Okay. Now going back to the equation on the previous page where we have the initial rate equals K2 times ES, we now have initial rate equals K2 times ET times S over Km plus S. Since we know that the maximum velocity Vmax is equal to the total enzyme concentration times K2, we can substitute Vmax into the equation to get the final form of the Michaelis-Menten equation, and we have V0 equals Vmax times substrate concentration over Km plus substrate concentration.